Hello, y'all. Welcome back to the second day of factoring. Last class, we talked about when A was not 1. Today, we are going to talk about when A is 1. And I think you guys are going to find this easier. We are also going to talk about something called difference of squares, like a special case. And then we're going to talk about how to solve by factoring. Okay, so 3 different concepts for us to discuss. Again, this is not from your workbook. So if you have a workbook, great, but this is not going to be found in there. We're going to do a little bit more than what's in the workbook, okay? So you just have to write these on your own piece of paper. I'm also going to upload, you should be able to find these blank notes on our page. So you can just print it off if you have a printer. If you're like me, you don't have a printer, so you just write it on paper, okay? So 2.3a, day 2, factor when a equals 1. We are going to use the exact same steps that we did in the last class when a was not 1. Okay, so the exact same things we did before is what we're going to do now. All right, so first and foremost, here's our first problem. X squared plus 8x plus 7. You'll see that I have 3 terms, so it's a trinomial, right, just like we had before. And in this case, all of these problems, look at the very first term. They're all a 1, right? In the problems we did last class, they weren't 1s. They were different. Now they're all 1s. It doesn't change how we do it. It actually just makes it a little bit easier for us, okay? So this is A, and this is C. Remember, C doesn't have the variable, all right? So I'm going to make a big X. Just like before, A times C would be 7 and adds to get 8. So you have to try to think of numbers that multiply to get 7 and add to get 8, which in this case, hopefully that's pretty easy for you. That would be 1 times 7. 1 times 7 is 7. And 1 plus 7 is 8. That's always the hard one. People forget about the 1 times the number. Remember, 1 will multiply into anything. Okay? So I have my numbers. I make my parentheses, just like before in the previous section. Whatever comes first, I put first. So this is just 1x and 1x. Then I put my numbers in. I have a positive 1 and a positive 7. The difference is whenever A is 1, you shouldn't have to divide either of these. Like x and 7 don't have anything in common, and x and 1 don't have anything in common, so we're done. Right? So it kind of eliminates a whole step. There's not going to be anything to divide by. Okay? It should all just work out nice and neat where we don't have to divide anything because they don't have anything in common. Okay? So look at this second one. All right, so let's make our x. First number is a 1. This is A. C doesn't have the variable. So 1 times 16 is 16 and adds to get negative 8. So it multiplies to get 16 but adds to get 8. So you might have to think about it for a minute. You have options. You have 1 times 16, but that wouldn't add to get us negative 8. You have 2 times 8, but that wouldn't add to give us negative 8. Or you have 4 and 4. And 4 and 4 would get us 8. But I need it to be negative 8. So that means I need both of these 4s to be negative 4. Because negative 4 times negative 4 is 16. Negative 4 plus negative 4 is negative 8. All right? So I have my numbers. I make my parentheses. Whatever came first, I put first. So 1y and 1y. And then I put my numbers in. So minus 4, minus 4. This answer is perfect. Now, some of you are looking at that and you're like, oh, yeah, but I think I could write that differently, right? There's 2 of them. So this answer right here is perfectly acceptable. Okay, if you would like to make it look a little bit prettier, right, you could write it as y minus 4 squared because there are 2 of them. These 2 answers are exactly the same. I don't care how you write it. Okay, they are the exact same thing. This one is the prettier, nicer version. Okay, but they are both exactly the same thing. So don't get caught up in figuring out which way to write it. Either one is fine. Okay. All right, let's do one more of these. 1y squared plus 4y minus 12. So we make our x. A is 1. C is negative 12. A times C would be negative 12 and adds to get 4. So we have to think about what multiplies to get 12, adds to get 4, or negative 12, excuse me. That would be 6 and 2, but 6 plus 2 is 8. I need it to be a 4, so I'm going to make this 2 negative. Because 6 minus 2 would give me 4. 6 times negative 2 would be negative 12. And then we make our parentheses. 1y came first, so 1y and 1y. Then put my numbers in. Plus 6 minus 2. The order you put these numbers doesn't make any difference. If you have the minus 2, if you put the minus 2 first and then the 6, it's the exact same thing. Okay, so the order that you put them makes absolutely no difference. That's our final answer. All right? So it's easier when the a value is 1, right? Whenever the first number in front of the square, in front of the variable square, that is always going to be a little bit easier than if a is not 1. Okay? All right, now we're going to talk about a special case. Okay, so this special case is called difference of squares. And you only use this in a very, very, very specific situation. Okay, so if there are only 2 terms, right, we couldn't use it up here because this has 3. 1, 2, 3 terms. So I can't do that. Only 2 terms. Both terms are a perfect square. And perfect squares are like 4, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25. Those are perfect squares. And it has to have a minus in between them. So it has to be subtraction, thus the name. Difference means minus. Squares means they are both perfect squares. Okay, so difference of squares is the only time this will work. If there's 2, if they're both squares, and there's a minus in the middle. If there's a plus in the middle, you cannot do this. Okay, it's not going to work. All right, so let's look at this first example. Again, pause it if you need to, if I go too fast for you. But if you look at this first example, x squared, that's obviously a perfect square. It has a square in it, right? And then 100. 100 is the same thing as 10 times 10. Okay, so that means it's a perfect square. Whenever they are both perfect squares and there is a minus in the middle, we're not going to make our x anymore, right? Because we don't have an a and a c. What we are going to do is split this up. Basically, just take the square root of each of them. The square root of x squared is x and x, just like we've always done. Whatever came first, I put first. Right? X squared, square root of that is x and x. The square root of 100 is 10 and 10, because 10 times 10 is 100. And then every time one of them is positive, one of them is negative. It doesn't matter where you put the signs. If you put the negative over here, if you flip-flopped them, that would be perfectly fine. Okay, it makes absolutely no difference at all where you put it. Okay, so look at this second example, a little bit harder. 4t squared minus 25. So you have to think to yourself, is 4 a perfect square? Yes, it is. That's 2 times 2. T squared is obviously squared, and 25 is the perfect square. And there's a minus in the middle. So all 3 things are true, right? They're both squares. It has a minus in the middle, and there's 2 terms. Okay, so that means this is difference of squares. So I'm going to split this up. The square root of 4. So basically, cut that, I don't want to say in half because it's not always going to be half, but the square root of that is going to be 2t in 2t. Basically, because 2t times 2t is 4t squared. The square root of 25 is 5 and 5. One of them is plus, one of them is minus. Again, the order of the plus and minus makes absolutely no difference. Okay, it doesn't matter where you put them. All right? Questions, confused, lost, some you don't get. Okay. So this last problem right here. Now, there's one little trick that you always have to remember when you factor. The first thing we always look for, and we did it last class, on every problem that we ever do when we factor, is look for the greatest common factor. 2y squared and 32 have a number in common, right? They have a 2 in common. So I need to take that 2 out before I can do anything else. And you're probably looking at this like 32 is not a perfect square. But wait, there's more. So if you take the 2 out, 2 divided by 2 just leaves y squared. 32 divided by 2 makes it 16. And now if you look in the parentheses right here, now those are both perfect squares. So just ignore that 2. Act like that 2 in front is not there until the very end. Let's just focus on inside, okay? So they're both squares, and there's a minus in the middle. The square root of y squared is y and y. The square root of 16 is 4 and 4. One of them is minus, one of them is plus. That's just from the parentheses. And then I keep that 2 right where it was. I just put it back in front. That's our final answer. Okay? So hopefully that makes sense. All right, there's one other thing we're going to talk about. Now we're going to solve them. So on all of these, all we did was factor them, right? The 3 down here and the 3 up here, we just factored. Now we are going to solve them, okay? So to solve by factoring, basically we're just adding an equal sign. It pretty much just add one step. But the key to this is that the equation must equal 0 before you can do anything. Okay, so the equation has to equal 0 in order for us to be able to solve by factoring. If it doesn't equal 0, you need to make it equal 0. All right, so it's going to be a lot of the same steps. We're going to do 2 examples, okay, because we're going to get a lot of practice with this in a little while. So this first problem, okay, it's 3 terms, so it can't be different to squares. There's no greatest common factor. 2, 5, and 2 don't have anything in common, so I can't take out a GCF. So what I have to do is A times C, just like we did before. 2 times 2 is 4, and adds to get the middle number, which is 5. So if we think about what multiplies to get 4 adds to get 5, that's 4 and 1. 4 and 1. So then, just like we did before, I make my parentheses. 2x came first. That's what I put first. And I put my numbers. Plus 4, plus 1. And it still equals 0. Okay? And then, like we did last class, right, we look to see if we can divide. I can divide this one by 2. This one, I can't divide by anything. So if I divided the first one by 2, it would be x plus 2. 2 divided by 2 is just 1. 4 divided by 2 is 2. Second one stays exactly the same. Okay? Now here's the one thing that's different. Now there's an equal sign, so I can't just stop right here. I actually have to figure out what the x value is. So we're going to do something called the zero product property. All right, it's not important that you know the definition, just have to know what it means. Basically, we want to solve this. So I'm going to take each parenthesis. In this case, I'm going to take x plus 2 and set it equal to 0. And I'm going to take 2x plus 1 and set it equal to 0. So I'm going to do 2 separate problems, and I'm going to get 2 different answers. So if I solved this first one, I would subtract 2. So one answer is x equals negative 2. So I solved it. Another answer, I would subtract 1. 2x equals negative 1. Then I would have to divide by 2. So x equals negative 1/2. So my 2 answers to this problem are negative 2 and negative 1/2. Right? Either one of those will make this true. If you put negative 2 in, you would get 0. If you put negative 1/2 in, you would get 0. Okay, so either one of them will work. There's 2 possible answers. All right. The only thing that's new is this part. This problem is exactly what we did last class until we got here to the black. That's the only thing that changed. We set it equal to 0. All right. We're going to do one more, so bear with me here. 6x squared plus 13x equals negative 5. I told you at the very beginning, the most important thing is that it equals 0. Okay, this one doesn't equal 0. But I could make it equal 0 pretty easily, right? If I got rid of this negative 5 and just added it to both sides, then my equation, so just add the plus 5 on the end. Now my equation is exactly like this one, right? It looks identical. So I'm going to do the exact same steps. I'm going to make my x first number, so a times c. 6 times 5 is 30. 30 adds to get 13. So we think about it for a minute. We think. What multiplies to get 30? 6 and 5, no, that won't get us 13. 1 and 30, no. 15 and 2, no. 10 and 3. So we are going to use the numbers 10 and 3. All right? So I split up my problem into my parentheses. 6x came first, so that's what I'm going to put first. 6x in both of them. Whatever comes first, put first. Then put my numbers, plus 10, plus 3. And then see if we can divide. And it still equals 0. I forgot my equals 0 on the end. 6 and 10, they both have a 2 in common. 6 and 3, they both have a 3 in common. So I could divide both of them. 6 divided by 2 is 3x. 10 divided by 2 is 5. 6 divided by 3, 6 divided by 3 is 2x. 3 divided by 3 is 1. All of that we did last class. Right? None of that is new. Now comes the new step. Now I'm going to take each one of these. So I'm going to take 3x plus 5 equals 0. And I'm going to take 2x plus 1 equals 0. And I'm going to solve each one of those, just like you've solved every other problem. So subtract 5. So that would be 3x equals negative 5. Kind of running out of room on my paper. Then we would divide by 3. So x equals negative 5 thirds. Just keep it as a fraction. 5 over 3 doesn't come out even, so negative 5 thirds. Do the same thing over here. Subtract 1. 2x equals negative 1. Divide by 2. X equals negative 1 half. So negative 5 thirds and negative 1 half would both solve this problem and make it true. Okay? We are going to get a whole lot more practice with solving, because I think that's a little bit harder than factoring. But if you have any questions, please reach out to me. I appreciate y'all. Bye-bye.